Welcome everyone to today's panel discussion on food technology in the 21st century. My name is Lauren DeJonvry, and I'm the Assistant Dean of College Relations and Development here at the College of Chemistry at UC Berkeley. And it is my pleasure to introduce today's talk. Today's panel discussion is the first event of our recently launched Berkeley Food Tech Ecosystem, which is part of a greater initiative to further engage you through various Berkeley ecosystems, where you can learn, explore, and connect with Berkeley faculty, alumni, students, and industry innovators on relevant topics. This year, we are launching the first 4 of our ecosystems, focusing on biotech, pharma, energy, food tech, and advanced materials, products, and technologies. We invite you to learn more about Berkeley ecosystems at ecosystems.berkeley.edu. Now for a few logistics regarding today's discussion. Today's panel discussion will be recorded, as will all future events. In the coming days, you'll find a recording of this event and other relevant content at ecosystems.berkeley.edu. We are planning to field questions today towards the end of our discussion, so please use the Q&A function rather than the chat function to share any thoughts or pose any questions throughout the discussion to our panelists. And finally, directly following our event today, you'll receive a very short survey. If you could please take a moment to give us some feedback on today's discussion, and more importantly, to provide us some input on future topics that would be interesting to you. Okay, it's now my great pleasure to introduce today's panel discussion on food technology in the 21st century. Food tech is an evolving and booming bioprocess industry, and we are thrilled to have Jason Ryder, a leader in this area, with us today to lead our panel discussion. Jason is a bioprocess engineer and entrepreneur with experience in process and product development, engineering, design, scale up, and commercialization in the industrial biotech and food tech sectors. Jason is the CTO and co-founder of Joywell Foods, which is focused on building the best tasting and healthiest sweeteners in the world. And additionally, Jason has returned back to Berkeley as an adjunct professor to lead the new Masters in Bioprocessing Engineering, an important program dedicated to training bioprocess scientists and engineers to design, develop, and commercialize new technologies and products. Thank you, Jason, for agreeing to participate in our panel discussion today, both as a panelist and facilitator. And I hand things over to you, Jason.
Thanks very much, Lo, and welcome everybody to our panel discussion today. And building off of Lo's great intro, the purpose of our Masters of Bioprocess Engineering is to grow and develop scientists and engineers to become much like our fellow bears and panelists today, who I'll introduce now. So first up, we have Thomas Shui, who is Senior Process Engineer at Amris, who uses their proprietary fermentation process to make a range of sustainable custom molecules for environmentally friendly products, ranging from cosmetics to anti-malarial drugs. Our second bear is Chae-Young Shin, who did her PhD here in chemical and biomolecular engineering, and she's co-founder and CEO of Sugarlogix, which develops yeast-based technologies to produce the missing component in infant formula, which is rare functional sugars found only naturally in human breast milk. And then finally, we have Rick Wilmer, who did his BS here in chemistry and is now CEO of Chowbiotics. Chowbiotics are the makers of the world's first fresh food robot. And again, welcome to all of our panelists, and excited to have our discussion today. But those of you that are watching remotely, we're going to start out by 35 or 40 minutes of questions that we've developed, and then we're going to open up to 20 minutes or so for questions from you. So you've got the next 35 minutes or so to think of your best questions. Excited to hear from you. All right, so let's start off with Chae-Young, and it's a question I'm going to ask all three of you, which is, can you briefly describe in a 2 to 3 minute elevator pitch what research project or initiative you're currently working on that most excites you, and why does it excite you so much? Chae-Young.
Hi, great to meet you, everyone. My name is Chae-Young Shin, like Jason introduced, and I'm the CEO at Sugarlogix. At Sugarlogix, we work on actually one thing currently, very focused, and we make human milk oligosaccharides, which are oligosaccharides that are uniquely present in human breast milk. Now, these oligosaccharides are very important because they basically play the fiber equivalent role in infant nutrition. And it plays a key part in developing the initial developing gut microbiome that colonizes within an infant's gut. This excites me very much because I was actually the baby who did not get breast milk, and the infant formula that I got did not include any of these oligosaccharides. And combined with the many fast foods and the white carbs that I've been fed growing up, it actually shocked me when I got more educated in nutrition as an adult to how nutrition, how crucial components of nutrition was still very much missing. So it excites me very much that I can apply the technologies that we have honed to really address this missing piece.
Great, thanks, Cheyenne. Rick, same question to you.
Yeah, I'm Rick Wilmer. I'm the CEO of Chowbiotics, and we are focused on automating food. And before the pandemic, food automation was starting to become practical from the perspective of core technology, things like microprocessors, artificial intelligence, machine learning, even robot arms and mechanisms, all were becoming mature enough to build a food robot that was financially practical and highly reliable, which is critical for a product like this. And when the pandemic hit, it changed things dramatically because food robots not only can eliminate redundant human behavior or speed up food processing, but they also can do it in a very food safe way. And that has clearly become very important now that we're in a very different world than we were, 6 or 8 months ago.
Great, thanks, Rick. Thomas, same question to you. What research project or initiative are you currently working on that excites you?
Thank you, Jason. So one of the things that Amris did, as you mentioned, is that we have amazing fermentation technology that allows us to scale up and manufacture brand new molecules that, the world has never thought that we could bring to manufacturing scales. And so I'm working on the development team that helps scale up and manufacture our molecules. And one of the things that I'm working on is that basically we're always focusing on the next scale-up campaign, the next manufacturing campaign. And as we're bringing these molecules to process, we're always decreasing development time. That's really exciting because we're learning from our previous ways that we can do better, and we're finding new ways to bring our molecules to market faster. And so two of them are, one's puricane, which is a rubioside M, and that's an extract from stevia, typically the natural source, but we're able to produce that via our yeast fermentation. And that's been wonderful in terms of basically helping substitute sugar in the current formulations of processed food. Great,
thank you, Thomas. So seeing a lot of innovation from Amris over the years, and Cheyenne, I want to turn back to you. Your company and mine as well, we're part of IndieBio, where a lot of innovation has come out through the different cohorts and companies over the last many years. And I'm curious to hear what trends you see that are transpiring in food tech, maybe coming out of IndieBio, maybe other places that excite or even concern you.
Right. So I have to warn you, I'm going to be focusing on nutrition a lot for the rest of the talk, probably as we work with infant nutrition. And really the trend to notice here is that we're making very specific nutrient components that carry high health efficacies by using microbial fermentation. So that is sort of that molecular production of the nutritional missing piece. That's really important. Now, while I'm very glad that the technology to produce these high functioning molecules are being developed, now there is a part that sort of we need to be cautious about, which is to not overpromise the efficacy of these nutrients. So for example, really promoting one type of phytonutrient to be the absolute solving piece for all your health concerns, for example, is something that we need to be cautious about. So really understanding the overall general aspects of the complex world of nutrition is very much needed to support this entire new way of manufacturing functional ingredients.
Yeah, so moving from the biomolecule more towards the consumer, Rick, I'm curious if you see the latest innovations and trends in a different way.
Yeah, I mean, from our perspective, we're building robots that deliver food to people. So the way people eat has been changing dramatically, and we've all experienced it. The advent of food delivery and getting whatever you want to eat wherever you are at any time of the day. There's been a change in consumer behavior, and it's very labor intensive. It's not economic, environmentally friendly. with driving cars around, delivering food to wherever you may be. And automation can provide a key role, and robotics can provide a key role in addressing a bunch of the challenges with the way it's done today, by making food available, fresh, healthy food available in very close proximity to you, the consumer, 24/7. So, for example, in the hospital environment, where you've got folks that are there, 24/7, taking care, unfortunately, today of a lot of COVID patients. The people that were working at the hospital after 8 or 9 p.m. when the cafeteria closed had access to vending machine food. That's all they got. Well, now we have the technology that can provide fresh, healthy, delicious meals to folks in situations like that they never otherwise had access to. And the evolution, again, as I mentioned earlier, of core technologies like microprocessors, artificial intelligence, machine learning, mechanical mechanisms to automate food are all advanced enough now where this can be done in a practical way.
Thanks, Rick. And back to you, Thomas. So I'm curious, as you spent many years with Amris, who's been a leader in industrial biotech and has adapted to also address some of these challenges in food tech. And I'm curious, from your perspective as a process engineer, how Amris has shifted or risen to that occasion.
Yeah, so we have a great commercial team that is always looking at where can we apply this technology and how can we make it better and how can we fulfill specific needs that we're seeing in the market trends. And so we, as you know, Jason, we started with a antimalarial drug, then we moved to biofuels, we've worked on cosmetics, we worked on a plethora of chemicals. And so Amris is fantastic at basically working on finding our biologists new ways to let's say exploit the strain to see what it can give us. And so there's lots of treasures in that strain, and so we're able to figure out what we can do to tinker with those yeast genomes and then basically ferment that and scale it up to manufacturing. And so we're always looking at the market, and so we're moving to the food space as well. We have our Pure Cane, which is a direct to consumer product that you can buy right now. It's great for your coffee. We have a few other flavors in the market as well. Some that I can't speak of right now, but we're always looking at what we can do and how we can move to different spaces and really leverage our technology.
Rick, I'm going to come back to you for a sec. I think I speak on behalf of my students as they're looking at a bunch of potential opportunities as they take their next steps beyond cow, and some put these in context of crises, right? And one of those could be around a food crisis. Earth's population is set to surpass 8 billion. And we need to feed everyone with healthy, nutritious food. What challenges do you see in feeding that population healthy, nutritious food, and what innovations are out there to help us do it?
Wow, yeah, our food system has got a lot of challenges. Not only is the population growing and the number of people we need to feed increasing, but the inefficiencies in our food channel are just shameful. The amount of food waste here in America is incredible if you dig into the data. We throw away so much food, and technology can absolutely help solve that problem. Part of the problem is just the inefficiency of the way food goes from a farm to a wholesaler to distribution and into an environment, be that a restaurant or a grocery store. And if you can use technology to predict what people are going to want and need to eat, and then use that information to go backwards in the supply chain, literally all the way back to the farm, for example, and match supply with demand, you can make a very significant impact on this problem. And with robots like ours, not only are we feeding people fresh, healthy food 24 hours a day, 7 days a week, but we're collecting all this data about who's eating what when. And we have this incredible treasure trove of information that can be used to the ends, like I just described earlier, to actually more intelligently run the supply chain from the bowl that the consumer's eating all the way back to the farm to try and optimize that and minimize food waste. And if you do that, you're going to be able to feed more people. The other aspect to what we do that's very beneficial is our platform is very inexpensive compared to a restaurant or a store. And within 20 miles of where all of we're sitting, there's things called food deserts, where the only thing accessible to an underprivileged community may be fast food restaurants with very unhealthy food. With a platform like ours, you can now start to provide access to much healthier food in a way that's affordable, that some entrepreneur can take into that community and deliver something much healthier to people than what they're able to get today.
Thanks, Rick. And while Rick's focused on getting at all of those 8 billion, Chae-Yun, you're focused on a subset of that 8 billion, but they're equally spread across the planet. What challenges do you see in getting, for example, the infinite nutrition that you're developing to that increasing population?
Yeah. So here, I guess the question is less about how do we feed all those children, because we can feed them anything basically, but then how do we feed them properly, really? And do we want to make it so that the people who can only afford it gets the right nutrition, and the people who don't get the right nutrition? And one way to address this is sort of along Rick's point, that we optimize the supply chain so that we can make the cost more efficient. The other way that we work on how to do this is on how to make the technology better so we can have a much more optimized manufacturing process. So I guess on our side, we're working hard on reducing the cost. And in a lot of industries, in a lot of nutrition industries, that should be the key focus on how we address feeding people.
Thanks, Chae-Yun. And Thomas, I know you're focused on costs. I was there with you for a little bit. And I'm curious your perspective and perhaps Amris' perspective on what that means in terms of conversion, right? I know a big part of what you're doing at Amris is converting sugars in sugarcane to some of these specialty molecules. And I wonder what the trade-off there is between the agricultural land that's used to grow that sugarcane versus what it could be used to in feeding people. Is that just a yield?
So that's a good question. So I think what we see is basically we're also looking at additional feedstocks as well. But when you look at what can be grown for sugar versus other kinds of food, typically we're always looking at sources that already are from sugar as well. And so it's not basically can this land be used for something else. It's basically this land is already being used for sugar, and we're finding a spare application for the sugar already. Because if it goes into animal feed or human feed, humans don't need more sugar, but we can actually use this sugar for some other kind of better uses, basically, feeding our yeast strains the sugar to then produce molecules that are actually doing better for the planet.
Yeah, I agree with that. We're working on something similar at Joywell Food, where we're making sweet fruit proteins via fermentation. And much like your Reb M, we're converting sugar to do that. And so for us, it ultimately comes down from repurposing that sugar as a feedstock for fermentation to meet all of the world's food needs. And it ultimately comes down to yield. All right, well, Rick mentioned data. Data is ever increasing, and particularly in the Zoom world we're living in now. Computers are becoming faster and smarter. AI, data and computer science here on campus and the world over. Robotics are changing the way that we do everything. Rick, what's your perspective on how that's changing how we produce and distribute food?
Oh, we're in our infancy, and boy, the imagination runs wild in terms of what we can do with that data. Just one example of something that we're working on. With all the data we collect and people that get food from our robots, we can start to understand how you're eating. And maybe the data that our robot is providing to you through your health tracking app now helps us anticipate what you want to eat in the future. Or, for example, based on that data, we can recommend a meal to you. As an alternative example, rather than come up to a restaurant, let's call our robot a micro restaurant, instead of looking at a menu and picking out what you think might taste good and be good for you, if that matters to you in that moment, you're posed with questions. I may be eating for energy, and I may need to avoid lactose, and I may be eating a Mediterranean style diet. With answers to simple questions like that, with AI running in the background, we can automatically build recipes that meet your nutritional goals, that don't contain anything that you don't or can't eat, that we also believe you may like. So these are just very early examples of some of the fascinating things we can do with the data about what people are eating and what you personally need nutritionally.
Thanks, Rick. Chae-Yung, I'm curious, are there applications that you see for AI and computer science and either the design and development of better sugars for nutrition or other elements of processes you're thinking about at Sugarlogix?
Absolutely both, in a way. So on the sugars that we make, it's actually very complex. So people actually don't understand fully the extent of the efficacies of the breast milk oligosaccharides. There are over 180 different types of these oligosaccharides found naturally in human breast milk. And their efficacy is in that they selectively feed the right good gut microbes. But then the exact mechanism of what types of microbes they affect and what they don't, and which ones they help fight off and which ones they don't, that is sort of in a very complex data pool. And all of that has to be sort of very well understood so that we can maximize on how we can introduce them in infant nutrition. So a lot of research has been going on combined with the works of the microbiome research on the application side. And on the development side of how we make these HMOs, I guess Jason and Thomas also has a lot of experience with it. But basically without the advancement of the data science, we won't be able to do this. Really, microorganisms are very, very complex. So as much as it would be ideal to have a very simple process where we feed them something and they produce something. They're live organisms. And so there's a lot of additional effects that go into play when we're trying to optimize for the manufacturing process. So there's a lot of data that's generated there. So yeah, I think without this advancement, we would not be able to use microbial fermentation to produce food.
Yeah, it boggles the mind, both literally and figuratively. Thank God for the computers to help us. Thomas, I'm curious, given Amris' world-leading position in transitioning strain engineering from what used to be walls of shake flasks into microtiter plates and robotics and automation that made strain engineering not a question of if, but a question of when. I'm curious, you're in Amris' position on pushing that boundary further beyond the robotics into artificial intelligence. Do you see opportunities to help in terms of the molecule selection or the strain engineering or even the production in producing and distributing food?
Yeah, so I think, I'm more towards the manufacturing scale production. So I'm going to talk more about that end of the spectrum. So, but I think as we learn about, more about what AI and robots can do, we don't really have that, I don't think many people have like that kind of AI technology into manufacturing right now. And a lot of times when you run a fermentation batch, it's a 5, 7, or 10-day batch. And, while you can make modifications during the run, sometimes you just have to wait till the whole run is complete, analyze the data and say, what can I do better for the next batch? So if we could basically use AI to say, okay, here's what we're doing, here's how we ran, let's say, hundreds of other batches, and have that AI kind of pick up what we're doing on batch to batch and figure out, okay, we're going to trend this way. How can we mitigate this issue to prevent this from happening again and increase basically the yield, productivity, the overall fermentation? That'd be fantastic. But I think we're trying to work towards that. But I think it's also like, a far way away.
Yeah, I love that answer. I mean, a lot of people think about Amris from, the great work we've done in strain engineering. But you have, one of the largest data sets, training data sets from all of the fermentations spread across the molecules. So I love that approach. COVID-19 has brought us all here virtually, because of the global pandemic that's continuing on around us. And it's brought disruptions not just to our ability to meet in person, but also to the food supply chain. What do you think the food industry has learned from this global pandemic? Chae-Yung, let me start with you.
Yeah. So I guess, it's not just COVID-19 this year, wasn't it? It was the fire, and there was a lot of natural disasters that happened this year that made us think a lot about how we're going to grow the business in the future. Because food and because also infant formula and infant nutrition is a very must-have components of everyday lives. The strategy that we're thinking about as a growing company is to really think about hedging our bets when it comes to geography. So basically not putting all our eggs in one basket is a strong strategy that we're trying to think about. And we're also thinking about natural disasters when it comes into assessing, for example, a production facility. And also when it comes to partnerships, we like to have partners actually if we're not located here. So that we can continue the operations even if some unforeseeable natural disaster strikes.
Thomas, building on the theme of your role in manufacturing, I'm curious your perspective on how this COVID pandemic has potentially interrupted manufacturing supply chains, which often for us as process engineers requires tech transfer and travel.
Yeah, so that's exactly right. So one of the things that we do is when we do manufacturing processes, we go out to the manufacturing facility and we are there on site to make sure it happens. Luckily, with the advent of great technology like Zoom, we can actually speak to the production engineers over there and kind of keep in constant communication as well with them. How we've disrupted the food supply chain, is I think one of the issues that is we see news reports of farmers kind of like tilling their fields because there's not enough people to pick the food, or basically we can't have the animals go to the slaughterhouse because they've gotten too big because they don't fit into that I guess that slaughterhouse mold anymore, so to speak. So I think the issue is we've optimized our supply chain so well that any kind of perturbations or disruptions kind of have a big rippling effect because let's say for animals, they don't fit into the machinery anymore. And so I think that's sort of an issue that we kind of need to look at going forward. It's like what happens when this specific size that we need does not fit into that round hole anymore.
Yeah, Rick, let me follow up with you on this question. As I think our chancellor made a really provocative comment that education will never be the same following this pandemic, as we've learned a lot by teaching remotely, particularly around inclusion, and I think we can never go back. I wonder if there are similar observations from your perspective on the food supply chain and how the food industry may never be the same again.
Yeah, I mean, we're all eating differently today than we were before COVID. How many restaurants have you been to recently? I haven't been to any. And it's sad to see our restaurant industries, our restaurant small business owners so impacted this way, but it has changed the way people eat. And the kinds of places people got their food before are changing. Restaurants are no longer sitting people down to serve their food. They're getting their food delivered. Grocery stores are booming. They're selling more food than ever. People are cooking at home. So this is all completely disrupting the supply chain and disrupting our economy and people's jobs. The other thing that is happening is that this is generating a major environmental impact. If you get food delivered to your house, or if you go and pick it up at the restaurant, look at how much packaging is included in your food compared to what you used to do back before COVID hit. So there are some very concerning impacts around this, both from a business perspective, from an environmental perspective, that I think technology can help address.
Great. So Thomas, I'm going to come back to you. This one's around the food tech industry. And I'd say there's a broader industry beyond food tech that extends into industrial biotech. I see them as very much related. How do we work together to instill greater diversity, not just in who we employ, but who we benefit and serve with these technologies, molecules, and infrastructure we're building?
Yeah, I think it's very important to be more inclusive and have a lot more diversity in all stages of like the company and leadership. I think one of the things that we can do in terms of employment is basically making sure we're have a commitment to hire, or sorry, at least interview at least so many diverse candidates, and also hire as many as we can that are well suited for the role. And I think also basically work with the communities, see what they need, talk to them, figure out how we can help them out, and really have a good community dialogue, and work with public policy makers, because they have their finger on the pulse of the situation, and making sure that we're talking with them as well, so we can get that input and figure out how we can best serve their community as well, and everyone in general.
Cheyenne, I don't know if this was one of the crises that you listed earlier, but your perspective on instilling greater diversity.
Yeah. An interesting question that I got from an investor about 2 years ago was when I pitched him our company's project. He asked me, well, why can't women just breastfeed if breast milk is so good? He didn't see a problem to solve there. And the fact is breastfeeding is very difficult to do, and it takes a lot of time. So in a lot of working women's cases, they're often not able to breastfeed for a lot of continuous days, which means that, well, people who need to go into work cannot provide the best nutrition for babies, which just absolutely doesn't make sense to me. I think everyone deserves the best of nutrition as possible. There are many different functions of food, but I feel like nutrition is one of the very basic human needs that we have to offer. Now, as an engineer and building an engineering company, our goal is to really strive for the highest efficiency possible so that instead of just creating a cool product that we sell to maybe like 1% of the population, we eventually make this a must-have and available for all type of nutritional ingredient.
Rick, same question to you, given that your interface is a bit closer to the consumer and has some deliberate calculus on how you're scaling out. How do you view diversity both internally and externally?
Great question, and obviously a very topical thing in the moment in our country, and we internally take this very seriously. We will constantly strive to diversify our workforce and are very thoughtful about including diversity candidates in every job we have open, from the board of directors all the way down to the entry-level position. Within the markets that we serve, this really comes down to affordability and accessibility. I'd mentioned food deserts earlier. Well, that's economics. If you can't make money as a food provider, be it a restaurateur or a store owner, in a certain community, you're not going to open a store there. So if we find ways through technologies like ours to make food more available to people in an accessible way, we can start to not only provide better nutrition to these types of communities, but we can also enable entrepreneurs in these communities to build businesses around the kinds of technologies that we develop.
Great. So I have one last question for each of you before we turn to our audience, and it's about our audience, many of whom are proud bears, UC Berkeley alumni. And I'm curious, if you were to talk to your earlier self when you were still a student here on campus, and knowing all of these great opportunities as well as challenges in feeding the world and applying food technology to do that, what would you tell yourself? And what would you tell, let's call it an undergraduate in the College of Chemistry right now that's thinking about getting started on solving these problems? Chae-Yun, let me start with you.
Yeah, it's a great question. What would I tell myself if I were to go back? Well, I guess for me, really understanding the actual real world problems out there would have really helped me get motivated, would have really helped to make the connection between what we were learning in class and testing out in lab, very, very fundamental science experiments, to the actual real world problems and in which ways they were meaningful. So that sort of thinking about bridging the knowledge and with the solution that we're trying to find, I think that would have helped me greatly.
Thomas, same question for you, and specific as a process engineer.
Yeah, so I think when you say, like, talking to a younger self or a younger chemical engineer, we always talk about the mass balance box where we draw our dotted lines. Okay, let's do the calculations in and out, how to solve that. And when you do that, you're solving all the problems that are in that box. And I think when you're in there, it's like, okay, the smaller the box, the smaller the problem. So as a young chemical engineering student, expand that box, put more operations in there, whether it's a chemical engineering plant or just a global problem or a community problem, and figure out, okay, how do we draw this box bigger, figure out the inputs and outputs, and make that better overall. So, stop looking at the smaller box that you try to figure out for the mass balance and do the heat and energy balance. Do it as a bigger box and figure out how to make bigger and bigger solutions for these challenging problems.
Thank you, Thomas, for bringing this back to mass and energy balances. CB is proud. Rick, your final word. What would you tell the audience or these College of Chemistry undergraduates and graduates that are looking to take their first steps into the world and maybe helping out in this crisis?
Sure, I could throw out the old cliche, do what you're passionate about. And I actually believe that's true. You need to do something that really means something to you, something that you care about, something that you're passionate about. But at the same time, you need to pursue something that you can be very good at doing that. You know, I would have loved to have played in the NBA. I'm passionate about that, but if I'm not any good, I have no chance. So it's a combination of passion, desire, and your education, your talent, and your ability to be very good at what you do. If you can combine those two things, you're going to find a good path.
Great, and I'll commend you all on your leadership. I mean, this is a big part of that and I think one of you mentioned this, is coming back on campus and telling the students about what you're doing, about your lens for looking at this problem and what you're doing with your hands to solve it. And if I were to go back and talk to my undergraduate self, it would be that, is to show at least a few examples of what is possible, because in their minds, everything is possible, and they're spectacularly aware of all of the issues that they're facing and the world's facing, but can't always make the direct connection about what they're learning and how that applies. And so that goes to the panel, and it also goes to all of our audience members, Cal alumni and beyond. Come back on campus when we all can, and when you can't, come back through Zoom and talk to them, tell them what you're doing, and any other way you can support them in getting ready to go out and solve this set of problems, as well as a bunch more. So with that, I think it's a good time for us to maybe take a few questions from the audience. So I'm going to be monitoring in the Zoom chat. So if you have a question, please feel free to drop it in the chat. Otherwise, I will just keep going and continue the conversation. So I'm going to give you the first pregnant pause to give you a few seconds to drop your first question in there. And after that, I'll keep going.
Jason, there's a number of questions for you in the Q&A area.
Gotcha. I see. That's a different dialog box. Thank you for that, Lo. All right. I'm going to start at the top and work my way down. So we have a question for you, Chae-Young, from Peter Lesby. How does, sorry, this is for you, Rick. How does Chowbiotics utilize AI?
We use AI in we use more machine learning than we do AI today. And the machine learning is really used within our closed looped control systems to optimize the way we dispense food, the way we deliver food. So we've got a lot of robotic mechanisms, mechanical mechanisms that handle different types of food, everything from low viscosity liquids like milk and water, for example, through very thick liquids like yogurt and then raisins, peanuts, up to very highly variable ingredients like chopped lettuce and things like that. So handling this diverse range of foods with all their different physical characteristics requires mechanics coupled with machine learning, where you're constantly optimizing and looking at how ingredients are being dispensed and delivered and changing the way the mechanics are moving to optimize that so you dispense very precisely. That's our biggest application today for machine learning. On the AI side, it really alludes to what I talked about earlier, which is marrying what people eat with what's good for them. So for example, if I go to the doctor and the doctor tells me, hey, Rick, you need to eat healthier. How do I translate that into what I order at the restaurant or what I do at the grocery store? This is where artificial intelligence can really come into play. If I have some idea of what eat healthier means, does that mean less calories, less carbohydrates, more protein, more types of nutrients, I can now interface with a robot like ours and provide information about my dietary needs and have that robot create meals for me or recommend meals for me that are good for me, that meet my nutritional goals, and that also will taste good. It's something I like to eat. So that's where we're starting to employ AI in some of our future software features.
Thanks, Rick. So our next question I'm actually going to field because it's spectacularly relatable to what our undergraduates in CB 170A biochemical engineering are solving right now. And this is around if you find, say, an enzyme with an interesting and relevant activity, how predictable is the ability to scale production of that? I'd say the answer today is very different than it would have been 20 years ago, only because we have so many examples of interesting molecules, whether they be small molecules or proteins like enzymes that have been discovered. Their utility has been determined, and someone has figured out how to make them in a recombinant host. It's just a question of when now, not a question of if. And I'd say it's spectacularly dependent on the enzyme itself, but I'd say there's a high probability that you can find a microbe or another host out there to make it. And there's lots of know-how in the industry, and I'll just pick on a couple, whether it's DuPont Nutrition and Biosciences down in Palo Alto or Novozymes up in Davis that can make it, or an early stage startup company like Sugarlogix or a Joywell Foods. And there's a lot of companies that are trying to do it. Thank you for that question. Next one, I'm going to go to Shirley Rivera. So Shirley says, and I just lost that. I appreciate the mention of environmental impacts. From a different perspective among the panelists, what are the various environmental regulatory approvals and or reviews, waste, water, air, your business, product, or services faced? Chae-Yun, you have a food product. Let me start with you.
Yeah, so in terms of the environmental impact, we try to avoid using harmful chemicals that would make it tough for us to go through any regulatory challenges. So from day one, when we optimize for our process and optimize our strain engineering, we ride based on the assumption that everything is going to be water-based and we're not going to be using any specific chemicals that are highly regulated. For us, the process of going through the regulatory approvals is relatively easy outside of the environmental impact, which actually we are mindful about since day one, because our products are naturally found in human breast milk, and they are generally recognized as safe. And now, because we also use a generally recognized as safe as a microorganisms to produce these molecules, we just have to show our process of using these grass organisms makes a grass product. Yeah, but it's something that we highly kept in mind from day one.
Same question to you, Thomas. Now that Amyris is making Reb M, which is a food ingredient, is the grass process something that's become more familiar to Amyris? And do you have other products that are going through regulatory processes?
Yes, so we have a regulatory team that's always looking at the evolving regulatory landscape and making sure that we're always compliant. And then that is always being fed back to our process development teams, making sure that we're always kind of making sure that we're checking all the boxes. And then in terms of the environmental regulatory impact, we perform a life cycle analysis on all of our products to make sure that we're at least determining what our footprint size is, and then figuring out the biggest buckets that we can work on lowering to make sure that we're minimizing the overall impact as we continue to do manufacturing.
Rick, I'm going to come back to you. I'm going to start with James McBrien, who led his comment the way I lead most of mine. Go Bears! But he says, we've seen global supply chains get devastated during the pandemic with scarcity of equipment and raw materials. How do you see the food manufacturing industry shifting to become more resilient from the global, national, and even statewide supply chains? And I say this from a perspective of someone waiting on a refrigerator going on 3 months. Rick.
Yeah, I see a lot of food production going local. Some of you may be familiar with the concept of indoor vertical farming, where you can build small indoor farms that in many cases are robotically automated. The products are hydroponically grown. You've got no risk of salmonella or E. coli because you're not outdoors in a field. And you can grow some very superior products, both nutritionally and from a taste perspective. And you can do this in very efficient real estate from an XY perspective. You don't need huge outdoor spaces to do this. And you now move the source of food closer to the consumption of food. And we actually partner with quite a few of these companies to get their superior products from the farm to a consumer. So I think that's a really significant change that I see coming throughout the country, and especially in Europe. We see a lot of initiatives like this as well, and in the Middle East, where the Middle East in general wants to become food independent, and they are now building out complexes to grow greens and products indoors in an environment like you see in the Middle East to become food self-sufficient.
Thanks, Rick. Building on the topic of leadership, this is a contribution from an anonymous attendee, and I'll pose it to the whole panel. So feel free to speak up if you have thoughts or strong opinions. From a policy perspective, the United Nations included a sustainable development goal to end hunger, achieve food security, and improve nutrition and promote sustainable agriculture. Are any of the panelists or their colleagues involved in exchanging research through this community?
So I'll jump in, Jason. We are not directly involved in exchanging with that community, but those goals are very core to what we do, and we help address those problems through technology.
Yeah, I would spectacularly agree with that comment, and I'd bring it back to Berkeley, as almost all things in my life come back here, as we have a unique position of leadership in the world through the technologies and the products that are developed from the technologies that happen right here on campus. And that puts us in great position to participate in those global conversations, as well as the local, state and national ones that we're more familiar with. So go Bears. Everyone should, that's interested and has the tools to work on this problem, should participate and share those best practices with the world, and the UN's got a great platform to do it. Here's another big question that I'll just open up for all three of you. Thinking big sky, how much of the world's food supply will eventually be replaced with biomanufacturing foods and ingredients in 10 years? That's a juicy one. Thank you.
So I'll try to answer this one. I think it's also a matter of how much do we want to replace the current food supply chain. For example, would you rather drink wine, or would you rather take a supplement of resveratrol that's found in wine, which is known to be a great antioxidant, by the way. And also, how much can we address through agriculture technology, or how much can we not? So it's a very balanced question that we want to be addressing. But if we're thinking about the doability of the technology, like Jason said earlier, it's a matter about finding the right organisms to make different things. So it's a matter of when and how much resources it goes into it. It's very, very doable that most of the nutritional components that we consume every day can be produced microbially.
Thanks for the second shout out to Mass and Energy Balances, Cheng-Yung. Any other guesses on that? If you could put a percentage on it, Rick or Thomas, how much of our food will be come through biomanufacturing in 10 years?
I'm going to leave this one to the bioprocess engineering guys.
I like to maybe touch on Rick's point about, vertical farming. I think bringing that to a lot more of, I guess, gray spaces that we have in our world. Like we have, old buildings that are not being used, or, old strip malls are just vacant right now because no one's going to them, or no one, and it's just in idle. So if we can turn that kind of, let's say, developed space into, urban farming, that'd be fantastic. And that way, like we talk about food deserts, we can bring that food to people who need it, making sure that we're working in the communities that, need to be served by this, food. So it's not maybe, biomanufactured food, but it's basically giving people the right food where they need it and delivering it closer to them. And that way you can reduce, all the footprints across, all levels of the supply chain.
Yeah, I love that answer, Thomas. And I'll only add to that. I have a foot in plant-based protein processing, and another foot, and perhaps a bigger foot, in fermentation-based. And I think the best processing is no processing. So where you can grow and distribute nutritious food without any processing, that's the best. But what we've learned is, plants do make some specialty molecules that can be functional and replace others. We're going through a big moment right now in plant-based products replacing animal-based products. And so I'd say that's where I see the biggest growth in that particular industry. Is we could see as much as 30% of the conventional foods that we've eaten that our supply chain's been built around that could be replaced by legitimately food tech, technologies that you're hearing about on this call, and others that you're not. One specific question to you, Cheng-Yung, from Winnie Leung. Can the sugar technology being developed at Sugarlogix for infant formula be applied to adult foods as a supplemental health item?
Yeah, the short answer would be sure, why not? I mean, we take a lot of different supplement items, but then the health efficacy in adults is not as well understood as in babies. So in babies are the oligosaccharides that we make, where actually there's a lot of scientific evidence that these carry immense health benefits for babies. It's not just a supplement, it's actually a must-have nutritional component for babies. For adults, the application is still being understood, but I think it would be highly effective actually in the populations that need a lot of help in the microbiome support, like the frail elderly population.
Thank you, Cheyenne. So we have about 8 minutes left, and I have 3 more questions, but I'm going to open this one up to the 3 of you, as I have a spectacularly focused point of view. And this one comes from Brian Mayorilla. Are your companies able to easily meet all your engineering and science staff needs, or are there areas where staff and suitable background are in short supply? Or current university training programs teaching the right things? Rick, maybe I'll start with you.
Yeah, this has been fascinating to see how this has changed as a result of COVID. When we all started to work from home, I was so worried about our ability to remain productive, and everything exceeded my expectations. And it's changed my mindset that I'm now open to hiring anybody anywhere. Whereas before COVID, if you weren't, here in Hayward, California, or within a commuting distance, you weren't a candidate. And that whole mindset has changed. So our recruiting universe has been opened up dramatically because of what we've learned through the COVID-19 pandemic and how we've used technology like we're using here, Zoom, to remain so productive. To the second point of the question, our universities train the people the right things to come into a place like ours and be productive? I would generally say yes. I'm very proud of Berkeley and pleased with the caliber of candidates that we're able to get. And I'm constantly amazed at how good and how fast new grads come up to speed and can contribute. I'm always amazed by that. I think we overvalue experience in many cases too much. And I think the educational system is doing a very good job.
Thomas, your perspective.
Yeah, that's a great question. So I think universities are doing a great job, especially go Bears Berkeley. And I think one of the things that we need to, what Rick mentioned is that basically we always want, we think experiential candidates are going to bring a lot more to the table, and they really do. And I think it's fantastic. But I think bringing, young, fresh undergrads to the companies is really good because they're bringing, the leading expertise of what's going on at the university level in terms of how to do the real quick calculations that, maybe, a person working 10 or 20 years might have forgotten or, might not do as quickly as them. And they come up with more of a curious mindset, maybe, that can help basically look at the data in a brand new way. Maybe use today's, data analysis trends to analyze the data and help come up, really interesting insights to what to do next.
Chae-Yung, are university training programs teaching the right things for you in Sugarlogix?
For the most part, yes. So I think actually the academic, the scientific education is impeccable. The quality of students that we get from UC Berkeley compared to anywhere else, it's very, very much noticeable. But I think it's the softer skills perhaps that can be better addressed in a way. So as a company is trying to use biotechnology tools to make food ingredients, we're trying to get together molecular biologists, analytical chemists, process engineers, fermentation engineers, downstream process engineers, and all of those people working together. And I feel like there's a lot of sort of untaught softer skills in collaboration that would be extremely useful when it comes to working with many different groups in industry. I remember teaching the communications class actually during my time at UC Berkeley. And at that time, I remember that it was very focused within the chemical engineering department. So in hindsight, I'm thinking, okay, maybe it would be neat to have people from different backgrounds and from different departments joining in and taking the communications class together so that chemical engineers not only know how to talk with other chemical engineers, but also know how to talk with biologists or business people and et cetera.
Yeah, so I have a unique perspective on this question, as I have 1 foot in industry and I have 1 foot right here at UC Berkeley. And I'd say there are some things that we're doing real well, but there's lots of things we could be doing even better. And I'd say the landscape's changed a lot in terms of, we now have needs for our bioprocess engineers that go beyond the conventional areas of biopharmaceuticals and industrial biotech. Which was not conventional 20 years ago, but now we have this brand new field of food tech and several others that need these bioprocess engineers to prepare for roles that never existed before. And so I think it's on us at UC Berkeley and all of our colleagues at other universities and colleges alike to partner with industry to make sure we're revising our curriculum to meet the needs of industry. And that's very much why I'm back here at UC Berkeley and why we launched the Masters of Bioprocess Engineering program. So I'd love to talk to anybody separately about that program and better yet, connect you with our graduates. Our last 2 questions as we're approaching the hour, I think are both to Rick. And I think they're both about robotics. How do you maintain the sanitation of a salad robot? Major health hazard if things go wrong.
Yeah, so I can see both questions, Jason. I got the Q&A panel open, so I'll just respond to both of them. We can maintain sanitization way better than any other solution. If you look at an old school salad bar, you've got ingredients sitting on the top of the bins exposed to ambient air temperature, and you're relying on some hourly worker to go dump that bin out and replace it with fresh ingredients at the right time. With a robot, you control all that with robotics and with software. So all of our ingredients are held just above freezing in a refrigerated chamber inside airtight canisters. And if that robot deviates from a specified temperature range for a specific period of time or more, we'll disable the whole robot and we won't serve anything that's been out of temperature range. Likewise, every ingredient that goes into the robot has a predefined expiration time. And if you hit that expiration window and there's still ingredients left in the robot, they don't get served. So quite frankly, health departments love what we do. Going back to the question about regulatory, we deal with health departments. And because we take the human variable out of getting expired food or food that's been held at a warm temperature for too long into a consumer's mouth, we do a much better job of providing sanitary, safe food to consumers than you could with any manual solution like we're used to. And then on the last question regarding how things are going to change in the retail grocery world, that's a great question. And it's been a market that's been booming for us. You all notice when you go to a grocery store, the prepared food is on the perimeter of the store. That's what gets people to come to a store and buy that commodity stuff that's in the center of the store that you can usually buy on Amazon. It's all about the food. And when the grocery stores lost their buffets and their salad bars due to COVID, we became very appealing to the grocery store world, and we've deployed into a lot of grocery stores now, replacing their self-serve food offering. So I think what you're going to see as the future continues, you'll see more and more robotic automated food solutions in environments like grocery stores, where it's not an open food bar with everybody touching all the utensils. They're machines where you build a meal on your phone or you touch a tablet on a robot and the robot builds your meal and off you go.
Thanks, Rick. And before I hand back over to Lo, I'd just like to thank all the panelists for joining today and participating in a great discussion about food technology, brought together through our common ties with UC Berkeley. I'd also like to thank all of our alumni and visitors who participated virtually, both through watching and as well as your questions. And we're not done here. Many more conversations to come in the future, and go Bears.
Well, thank you, Jason, for agreeing to both facilitate and be one of the panel discussion folks here today. And yes, I reiterate our thanks that you stated. It was a great event today. I learned quite a bit myself about the food tech industry and the future of it. We hope you'll join us for our next Berkeley Ecosystem event. That will be a panel discussion on the future of batteries and energy storage on Thursday, November 19th at 11. And just as a quick reminder, please take 2 minutes to complete our survey, not only to give us feedback on today's event, but suggestions on future programming. With that, we hope to see you again. And until then,